We call another, which is seldomly used in Hong Kong, but that we first introduced in this project, we call shell. Okay, keep out. Since the cell is still lightweight, but it's a little bit more denser than that of expanded clay, and but the strength is much stronger. You can see compared to 1.2 here, it's 4.1 and 6.1 depending on the density. And there's another material that we use, which is for the second generation that we produce it ourselves. Okay, we call the lightweight cold shell aggregate, which is an innovation that is developed between us and university in China. And this lightweight aggregate does not need sinterate, does not need high temperature. You use a cold bond technology I'll share with you. It has super strong, okay, 10.84 crushing strength, and the density is a little bit higher. Okay, so and then this the water absorption better. So we make use of a strong aggregate to lightweight aggregate to make our concrete. And then this is the image of one of our poly produced have a particular water absorption behavior. We need to develop our own specified mixing process so that to enhance the workability and also enhance the strength. And in this particular case, we developed a protocol of water addition. Okay, addition of half the water initially and then half the water towards the final stage, and then using a very low water cement binder ratio is 0.25. Okay, and then this is, and then we can produce a string, and then this we can just highlight the green one. This is polyU pre-wet technology. I mean, all the lightweight can need some pre-wetting. Okay, and then our technology can produce a 20-day string. In this particular case, right, a very high string, 46.6. Okay, so we can produce a good binder using our good concrete or using our technology. Okay, a strong binder, a low carbon binder using GBS thinner film to replace OPC, using a very low water binder ratio, and then using we call the fine aggregate. Okay, the lightweight aggregate in this particular case is the shell, and then we produce a strength, something like that. This is in the lab. Okay. And this is actually in the plant. When we go to the plant, it's even better because maybe the production process is a little bit different from the lab. And then for C30 concrete, this is the result that we use for the actual MIC produced for this particular project. And this is the C30. We are looking for C30 concrete, right? The density, normally, the density of our concrete is 2,400. Now we can reduce it to 1,750. And then the acute compressor strength at 20 days is 60 MPa. Okay? And then the cylinder compressor strength is 40 and etc. etc. And yes, the CO2 in the air could penetrate to the middle of the concrete, so the steel will become depacified. Okay, but now we can say that there is no carbonation during the entire test duration. So the concrete itself is very durable. Okay, this is the C30. Now we go one step beyond that. We go for another technology, use the core shell technology, C60. We can actually produce a very high, we can be used for high strength concrete actually. And then even the chlorine diffusion is 0.3. Yeah, so almost impermeable to chlorine. Okay, this is quite amazing, I believe. This is quite good. Okay, so the polyU techniques, no carbon high performance binder with use of GBS and silicon, high specific strength lightweight aggregate. The aggregate is high strength, and high specific strength means high strength, low mass, and high specific strength and better ITC property. ITC means the bonding. Okay, that is what we found. Okay, And that's why we used it with the CDD support. We use it in the first structural grade lightweight concrete in Hong Kong. Okay, that is we use it for MIC. The MIC is a steel frame, as I said. It's a steel. The frame is steel, but the concrete, the slab is a concrete slab. Normally it's very heavy. You think OPC is very heavy, but now we use it lightweight, and then the density is something like that, and then we produce it in the factory and fabricated everything in China in a precast plant, and then ship it to Hong Kong and assemble within. It can be done within 2 days. This particular assembly, and then it's now therefore that is completed and is being used, and we are still monitoring the deflection because we are worried about the models, right? We are monitoring deflection, and so far it's okay. So this is the shipment of the unit to Hong Kong. Okay. And this is showing the casting of the concrete in the plant. Okay, this is another, the high grade one. We also, it's not used in the government project yet, but we hope we can. But we have produced it successfully in another precast plant. And then this one, we actually making use of two type of lightweight material. One is for this very high strength 75.3 28-day lightweight concrete at density of 1827. Okay. Another technology we utilize for this particular application is a trial. Okay, it's a kitchen. Okay, the wall are produced with the C60 concrete, but the partition are produced with the coil foam concrete. Okay, and then foam concrete, of course you know, right? Foam concrete is for non-structural application is a very light. And then what we have done is to use a low carbon binder using our foaming technology developed by ourselves, and then using a lot of GGBS, and then the concrete is 1,300 kilogram per cubic meter, and now very good strength. Okay, so very good strength, and then the thermal, particularly we are interested in the thermal conductivity, and then this could be done. Okay, so the whole thing, if you are interested, the government maybe, the housing department maybe, they are using a full concrete MIC. So the wall and thing could be used for particular high strength, but the non-structural one can be used, can use the foam one. Okay, so I think this is quite exciting. Okay, so that is what we carry out in the plant, and then this is this is the material that we produce. It not only lightweight but also low thermal conductivity. Means it would not, when we are using in external wall or external partition, it can be used for resisting heat gain from the sun. Okay, so that is very interesting. Okay, so I think I only have 2 more minutes. I'll just tell you one thing that may be of interest in the future development of further reducing the carbon footprint of concrete is to use glass powder. Okay, glass powder. Now, glass powder, Hong Kong is we have just the wine and dining festival. Okay, last week a lot of wine bottles. Right? We are trying to use glass, waste glass, to replace cement, to even further reduce the carbon footprint. GBS is already a very good material, but glass even is better because it's totally waste. And then what we found, compared to PFA, FA is PFA, glass powder can actually have a comparable strength contribution to that of PFA. Okay, PFA is generated from power plant, but we are running out of coal-fired power plant nowadays. So we're looking for substitution. Now, GBS is a good candidate, but when we have so much glass, 200 tons per day in Hong Kong every day, okay? And then we make use of some of the glass to substitute cement. Using 20% replacement, we can produce a concrete or cement paste with equivalent strength to that of pure OPC paste. Okay, and that is quite good. And then the carbon footprint of this particular material is even better in HBS hockey. So we have tested a lot of property of this, okay, strain gauge, compression strength, etc. And then there's no problem. Okay, I think that if you're interested, you can look for the we are from the university. We always publish. Okay, you are most welcome to look at our papers, and yeah. So I don't have time, but I would like to. One thing that is even more exciting is our core shell technology. Now, as I said, we can make use of we can synthesize our lightweight aggregate. Okay, we can use different type of lightweight in the middle. Okay, the lightweight material in the middle, like okay, bauxite, like EPS, okay, polystyrene, papugao, use perlite, and then in the middle it's just occupy the space in the middle, and then we cover it with our low carbon binder like okay, GBS, OPC, glass powder, and then what is exciting here is we use a CO2 cure. CO2 means a waste CO2, and then this shell actually can capture a lot of CO2 because it contains a lot of calcium. Right? To capture a lot of CO2, sorry, and then the capture of CO2 can actually harden the material, make it very strong rapidly. Okay, this is we call carbonation technology used in concrete, and then we call it really not only use CO2 but also reduce the carbon footprint of the whole material, and then very high strength and low density as well. So it is quite exciting. There's a lot of development in this area, and we hope we can work with various government departments, particularly CDD, so that we can help to decarbonize the Hong Kong as well as the industry. Thank you very much.